What causes the water table to change dynamically? Imagine standing on a piece of land and watching the ground level shift up and down like a heartbeat. That's because the water table is always moving. It's the top surface of the underground water stored in soil and rock. This level isn't fixed. It changes all the time based on many natural and human factors. When rain or snow melts, water seeps into the ground through permeable soil and rock layers. This process is called recharge. The more water that infiltrates, the higher the water table rises. But how much it rises depends on how easily water can flow through the ground. Sandy soils let water move quickly, causing the water table to respond faster, while clay soils slow things down. Vegetation also plays a role because plants absorb water, reducing the amount that reaches the underground reservoir. On the flip side, water leaves the aquifer naturally through springs, rivers, or when it seeps into lakes and wetlands. Human activities like pumping water for farms, cities, or industries also take water out. When more water is pumped than replaced, the water table drops. This can happen quickly if large amounts of water are extracted, especially in dry regions. Seasonal changes also cause fluctuations. During rainy seasons, the water table rises as recharge increases. In dry seasons, it falls because less water enters the ground and more is used or evaporates. Long-term climate shifts like droughts can keep the water table low for years, stressing water supplies. The physical features of an aquifer matter too. Aquifers with high porosity and specific yield can hold and releases more water, making the water table more responsive to recharge and withdrawal. If an aquifer has low porosity, the water table won't change as much even with significant recharge or pumping. Surface water interactions influence the water table as well. Flooding can temporarily raise it by saturating the soil. Urban development often reduces recharge because concrete and asphalt surfaces prevent water from soaking in. This can cause the water table to drop over time, especially if natural recharge is blocked. Chemical and biological processes near the water table can also affect groundwater. Microbial activity and chemical reactions can change water quality and influence how water moves underground. Seasonal shifts in water levels can bring oxygen and nutrients into the aquifer, affecting the environment around it. Understanding these factors helps us manage groundwater better. Monitoring water table changes guides us in setting sustainable pumping limits and planning recharge projects. It also helps prevent problems like land subsidence and protects ecosystems that depend on groundwater. So, the water table is always in motion, balancing water coming in and going out, shaped by climate, land use, and the underground environment.